Good morning. My name is Janelle Millman. I'm a botanist and ecologist at Santa Clara Valley Water District in San Jose. This is the first of 2 sessions on Phytophoras in restoration areas. I can't think of anything more disheartening than the inadvertent introduction of pathogens via restoration activities into the very areas that we're trying to restore and protect. But despite the dreary subject matter, we're going to do our best to make it fun. And our first speaker today is Ted Swiecki. Take it away, Ted.
All right, thank you. Diseases can be fun. I'd like to acknowledge our support comes from the California Department of Fish and Wildlife through the Santa Clara Valley Water Habitat Agency with cooperation on this project with these Santa Clara agencies. And I'll have to try to advance that case with this lead speaker. So why are we even looking at this as an issue? Well, it goes back to 2002 when we were working on disease problems in inland and groundlands, and we found that Phytophthora syndrome was causing vast mortality of this endangered species. And some follow-up work in subsequent years, we found another Arctostaphylos in the East Bay Hill, which is also being affected by D. cinnamomum. And through other work, often in our sun-upset sites, we're also finding mortality and decline of things like madrone, bay, chinkapin associated with D. cinnamomum, also these wildland sites. And this is a more recent find, and remember, I'm purposeful body going into decline. This is on the mid-10 open space lands. So through just a bunch of miscellaneous projects over a period of how many years that is, we were finding Phytophoras in wildlands across a wide range of different dry habitat types, most of them being cinnamomum carnivora, but other species. So now to take us into Santa Clara Valley specifically, well known as an agricultural valley before it was known as the Silicon Valley. We started out there with not delightful situation, which was restoration planting where all the stock was heavily infested with Phytophthora. So that gave us sort of a red light to that we had some issues here with nursery stock in that location. We also found an older restoration planting where we had mortality associated with a number of different host species, native host species, from an array of Phytophthora species that have been associated with this original restoration planting. And so between 2014 and 2016, we were doing sampling, and the Rizzo Lab did a large project for Santa Clara Valley Water District where we sampled restoration sites that have been done mostly fairly recently with some older ones. And these are the numbers of Phytophthora taxa that were recovered from individual samples in either transplanted nursery stock or in water samples. And you can see the Rizzo Lab at the high power record has 8 species of Phytophthora from a single sample. So we knew that Phytophthora was getting out into these areas by nursery stock, and that was a big issue. So this project was associated with a Natural Communities Conservation Plan for Santa Clara County. And knowing that we have these potential impacts, we were trying to set some sort of baseline. What kind of threats might be out there? These are 50-year plans, so you're trying to plan for management of these wildlands over a long period of time, these habitats. And we hope to be able to use this information then to come up with good management plans on how to deal with these issues. The actual planned area is shown in the red outline on this map of Santa Clara County. So really we're looking at 2 types of things. Where might Phytophthora have been introduced into these settings? And with that information, what might we do to either minimize further spread, new introductions, or to minimize future impacts from these? So we're going to go through and detect Phytophthora in habitats. This is not going to well, basically, we use baiting for this, pretty straightforward soil baiting to collect roots. What happens a lot of times when you're digging roots, you have relatively low root density from soil samples, so we'll concentrate that by picking through that and concentrating more roots in our samples. Those samples that are pre-wet to field capacity for several days before they're flooded, and then we get lesion on pairs that we can isolate from. And we can do similar sorts of things to baby water bodies. We just skim the surface water, which those of course come up to the surface. We can float kerosene up and pick out the Phytophthora from those the same way. And we know that bathing is a fairly efficient way to do these types of detections. We had a split sample test we did in one of these Santa Clara areas earlier. We had a number of samples processed by direct isolation with support of immunoassay and PCR. And we also bathted those same other halves of those same samples. You can see our detection efficiency is much greater with bathing. It's not going to be 100%, but it does show that you can, with the large amounts of roots you have there and the bioactification you get in that system, you can pick up more things. So the reserve system for Santa Clara County are all these polygons shown here. We cover a fairly wide area, and this is how we're going to do our sampling. So you can see there's kind of a size mismatch here. We can't use brute force to take random samples across this whole thing. So instead, we're going to use our phytopathology wiles to figure out where we should sample to increase our probability of having positive results if there's results to be found. So really, this is all about prioritization. How do we prioritize in a large area where we're going to sample? And so first we look at this kind of simple risk model. How do we decide how to get into areas? We have some sort of source, and we can categorize sources relative to risk. There's some kind of transport mechanism, and then it's moved to a sink, which has to have susceptible vegetation. And all those things have risks associated with them that are on a sliding scale. We already knew that nursery stock of various types, whether it's restoration or horticultural, are very high inoculum density sources. But if we have an infested area like the Simone pest, that's also a high inoculum source. The amount of contamination transported can be small, it can be on your shoes, it can be on big equipment, or we can take a lot of, we can multiply things, like planting a lot of nursery stock out at one site. And then the receptivity. This could be a whole pile of inoculum sitting here, this stuff, but we have annual grasses that are not really receptive posts by and large. Whereas if we have a lot of different root rot posts in the area, we don't even have to move much inoculum to potentially have an issue. And that receptivity is a function of both root density and the environmental conditions at the site at the time when transport might occur. And so the final thought is that all this is multiplicative, that if any of these factors, the risk is really zero, then the overall risk is zero. So if we start from a site where there's no Phytophthora to be moved, or we don't move the Phytophthora through root sanitation practices, or if there's no likely host, we're not going to have a likelihood of movement to those, and we're not going to look at those sites. We're going to concentrate on sites where we think there's some risk. So to look at the vegetation that we have here, we can go to vegetation maps of the county, and we can based off the hosts that are present there, we can get an idea of which ones are a higher priority or higher likelihood of being infected. We overlay those with these priority vegetation types. And in the NCCP, we can also restrict it down further where we might want to concentrate for sampling. We can also look at the chances that these sites have been contaminated, both where are they remote or they're closer to sites where things are happening, whether nursery stock or old orchards or other kinds of things going on. So if we use urban settings and agricultural settings as a surrogate for that, we can map that out as well. And finally, there are finer scale types of things that tell us about how likely there's been a chance of contamination. Business area. Okay, so we're looking at other site factors and that relate to whether or not we had a likelihood of introduction or routes of introduction. So here we have a parking area compared to a wild area. Previous agricultural practices, small grains or pasture might be different than old orchards. And if we have vectors such as livestock that can move around soil in wet areas or large equipment that can move in soil, those are the types of things that we want to look at for risk. So we put all this together into the GIS, we overlay it with aerials, and you can obviously see the erosion sample from this. Right? Yeah. At one point I knew what these things meant too. I had no idea. But the bottom line is that GIS can help get us into the area, but it doesn't really points you right to the spot, because a lot of things aren't visible through all those analyses. That small things like these little plantings around this area don't show up anywhere. We find that there are just mapped vegetation types here. So that hill that is chaparral really is mapped as grassland. These valley oaks are mapped as blue oaks. And if you're looking at things like vegetation symptoms, none of that's going to show up on any of these things. So if we're looking for symptomatic plants, we really have to observe that. So through all these processes, again, we only have a limited budget, time, and we're looking at reconnaissance level. So we hit up almost all the reserves where we thought there was high-risk vegetation, and these are the places where we had detection. In all, we did 181 samples. 29% of those were positive overall for Phytophthora species. All but one of the locations had Phytophthora present. Even in some cases, these are the total numbers of samples at those locations by these kind of different soil moisture regimes. And you see in some layers we didn't have very big samples, we still had picked up Phytophthora in those sites. One way to look at this is across the soil moisture gradient and from water. And if you look at the horizontal bars there, the fraction within those categories that were positives. And in general, for water and seasonally wet areas, we're more likely to pick up Phytophthora than we are from dry areas, but we still have hits in all those sorts of situations. We didn't spend a lot of time looking at nursery stock because we knew it was infested, but a few places we did, and we certainly found infested material there. And this last category was a special little sample. We throw that in separately. We happened to be at this site, and we sampled that by means of using our shoes and walking on the trail while it was still kind of wet. And we were able to pick up grass and myrrh just from those boots. And so we and the cows that were out there were happily moving this stuff around on our feet. Of course, we got our heart cleaned off. Overall, we had 20 Phytophthora taxa that we found. Most of them, the highest diversity, was in these sort of seasonally wet areas. You see there's overlap of the species occurring in dry and seasonally wet and seasonally wet in water. Not so much across all three types of situations. And several of these are fairly commonly found already. Others, like Phytophthora taxonomy or folium, we've only found once before. That's an undescribed taxon. Okay, so for these CNPS species, which one are the focus of one of the protected plants in the plan, we sampled all the three populations that existed for that. And when we went to these upland populations, we looked for the shaggiest looking plants we could find there, because those would be the ones most likely to have Phytophthora in these areas. And luckily, at least in this population, we didn't find anything in these uplands or associated with CNPS. We did pick up one Phytophthora hit out there, Data. This is a spring-fed pond, so basically it had to be moved there by cattle or livestock. And we saw that type of pattern in other locations. This other population, uplands again, even though we had some mortality there, none of that was apparently associated, or we didn't isolate any Phytoptheras, but in these wetter areas, through drainages, we picked up a number of Phytophthora species associated with both some native and introduced vegetation. And just for greens, we sampled a couple of water puddles, and sure enough, Phytophthora was in there. This particular site is the largest population. This is this Anderson Dam area. These upland sites off to the left, some of these were sampled as part of other projects, but uplands undisturbed, we were picking up basically did not find Phytophthora at all. But you can see this really hot spot down here, where we had a lot of different species in a small area. And that was associated with earlier planting of nursery stock, and it had expanded to a fairly large area. And the percent positives in that area are very high compared to other situations. There's also some evidence that through trail use or road use that one of these species may have been moved over to this other area which is not infested, and that was a toy on hit in that area. There's also this kind of odd situation where we have all this mortality along the high water line, and a number of different Phytophthora species, including P. taxonifolia, showed up there. These were associated with a high water event. This these are well below the normal water level. Everything in this area, they got temporarily inundated, dead, and we have found all these different Phytophthora species there. So this is close to the high water level. This is what it would look like normally. And what we actually think is that a lot of this inoculum bracted in from these subdivisions over here as all these floodwaters came through, debris and everything else was going. I see that I'm out of time, so I'll just flash a few pictures just to show you a couple of situations. Uplands and wetlands, uplands and wetlands, uplands, nursery stock. Not a good situation here because you're at the top of the watershed, so that Cannon River has a chance to work all the way down. Here's the site. We only took 4 samples, 3 of them were positive. So where do these things come from? There are roads, there are trails, there's urban and whatever development there, but a little bit mysterious. Here was the site where we picked up initially this After not really described species. So we did some further, and that was associated with declining bag. We did some further sampling upslope. We found everything but that particular thing. We do have other sources upslope, but a lot of these sites you can't really figure out exactly what's going on. However, even without knowing that, we know that running cattle between these areas poses a risk. So we already have enough information to say, don't change your grazing practices or you're going to have a good chance of contaminating other sites. This last one is just a kind of a show and tell of a lot of different things in one place. Cannon River in a likely spot, full of orchards, less likely spot, upland, still disturbed there. We looked to see if it might be down below. We actually came with agrifolia again. And in this area, we had another rare undescribed species, the Phytophthora line. And so one of our questions is, where are these things coming from? And what are their impacts? Because we also very little about them. So in summary, we detected Phytophthoras in almost every of our locations we sampled. Most of them were more associated with identified risk factors. If the risk was low, we were unlikely to pick it up. The Sanderson Lake, the most, and nursery stock is the likely source. Most of the diversity in these more wet areas, and we think that both you have to consider this for sustainability of your sites as well as your adaptive management of your sites. I don't want to flat out of time, but thank you.